Good day, class. Welcome to Playing Tricks in Mathematics. In our last video, we discussed about multiples and common multiples of numbers in mathematics. Today, we want to look at another concept of multiple or multiples, which is lowest common multiple, generally known as LCM. The simple meaning of LCM is just a number that the given set of numbers can divide individually without any remainder. Let's say I have 2 and 3. The LCM of 2 and 3 is 6. So let's put 6 in our definition of LCM. 6 is a number that 2 can divide without any remainder and 3 can divide without any remainder. That is just simple meaning of LCM. Now, let us look at how to find LCM of numbers in mathematics. There are 3 ways or methods of finding LCM of numbers in mathematics, but we'll look at the simple ones out of those methods. One, you can find LCM of numbers by first finding the multiples of each of the numbers, then look at the common multiples of those numbers, then pick the lowest one. That method might be too complex to use considering time, but I will only recommend just 2 methods that are very simple to find LCM of numbers in mathematics. The first method is dividing by prime numbers. You can find LCM by dividing by prime numbers. The second method, which I like very well, is using products of prime factors. We're going to use the 2 methods so that you can understand how easy it is to find LCM of numbers in mathematics. Let's use examples to guide us. Examples. Let's say you have a question that says, find the LCM of the following numbers. 1, 18 and 24. 2, 12, 18 and 27. We're going to use the 2 methods to solve these questions. Now, let's start with the first one. We want to look at LCM of 18 and 24. So, method 1, which is dividing by prime numbers. So if you want to use this method, you are going to make a table like this. You put 18 here, you put 24 here. Now, you now start with the lowest prime number. Let's start with 2. 2 in 18, 9. 2 in 24, 12. You can still use 2 because of 12. 2 in 9. It's not possible to write 9 again. When the prime number used cannot divide the number without any remainder, then you write the number. 2 in 12, 6. I can still go with 2. 9. I have 3. I can't go with 2 again, so I can go with 3 now. 3 in 9, 3. 3 in 3, 1. I can go with 3 again. 3 in 3, 1. 1. Once you have 1 or 2, then you stop. Then you now write your LCM. LCM equals 2 times 2 times 2 times 3 times 3. Then you multiply out. 2 times 2, 4 times 2, 8. 8 times 3, 24. Then 24 times 3. 3 times 4, 12. You write 2, you keep 1. 3 times 2, 6. Plus 1, 7. So 72. So the LCM of 18 and 24 is 72. And if you look at it very well, you can see that 18 can divide 72 4 times, while 24 can divide 72 3 times. So this is correct. So that is method 1 for this question. Now let's use the method 2 to see if 72 we got from method 1 is correct. The second method is using product of prime factors. What we do in this method is that we will find the factors of 18 and 24 separately. So what is 18? Let's look at the meaning of 18. Let's start with 2. 9. 2 cannot go again. We go with 3. 3, 3, 1. This is 18. Let's go and see what 24 is. Let's start with 2. 12. 2 can still go. 6. 2 can still go. 3, 3, 1. Once you reach 1, then you stop. Then 18 is 2 times 3 times 3. 24 is 2 times 2 times 2 times 3. Alright? Now, listen and listen good. After you have defined each of the number like this, then you have to use index notation to write them. Let me write them in index notation. This will be 2 times 3 raised to power 2. Then this is 2 raised to power 3 times 3. Now, how do I pick these numbers to have my correct LCM? So, if I want to pick 2, I'll pick 2 with the highest power. You must pick all the numbers represented in the prime factors, right? So, if I want to pick 2, I'll pick 2 with the highest power. If I want to pick 3, I'll pick 3 with the highest power. Then let's pick them. So, LCM will be 2 raised to power 3 times 3 raised to power 2. 2 raised to power 3 is 2 times 2 times 2. That is 2 times 2, 4. 4 times 2, 8 times 9. And 8 times 9 is 72. So that means our answer is correct using the 2 methods. Now let's look at the second question. Let's start with the first method, dividing by prime numbers. Let's draw our usual table. Put 12 here. You put 18 here. You put 27 here. Let's start with the smallest prime number 2. 2 in 12, 6. 2 in 18, 9. 2 cannot go in 27. We have 27. We can still use 2. 2 in 6, 3. 2 in 9. Write 9. Can't divide it. Then write 27 because 2 cannot divide it. Then let's go with 3. 3 here, 1. 3 here, 3. 3 in 27, 9. Can still go with 3. 3 in 1, 1. 3 in 3, 1. 3 in 9, 3. Can still go with 3. 3 in 1, 1. 1. 3 in 3, 1. Now everything is 1, 1, 1 all true. Then you stop. Then now write it like LCM is 2 times 2 times 3 times 3 times 3. Let us multiply out. 2 times 2, 4. 4 times 3, 12. 12 times 3, 36. 36 times 3, this is 18. 108. 108. So the LCM of 12, 18, and 27 is 108. That is a number that 12 can divide, 18 can divide, and 27 can divide without any remainder. That is 108. 12, we'll see 12 9 times in 108. That is 12 times 9, 18, 108. We'll see 18 6 times. 18 times 6, 8 times 6, 48. Right? We keep 4, we write 8. 6 times 1 is 6 plus 4, 108. So we see this 18 in 6 times. 27, we see it in 4 times. 27 times 4, 4 times 7, 28, keep 2, 8 times 2. So that is 27 is 4 times. So that is the first method. Now let's use the second method, that is using product of prime factors to see if we are going to get 108 we got from the first method. Now let's define each of the number using product of their prime factors. What is 12? 2, 6, 2, 3, 3, 1. Right? What is 18? 18, 2, 9, 3, 3, 3, 1. What is 27? 27, 3, 9, 3, 3, 3, 1. Now let's put them together. So 12 is 2 times 2 times 3, right? 18 is 2 times 3 times 3. Then 27 is 3 times 3 times 3. Now the next thing is to write them in index notation, right? Write them in index form. This is 2 raised to power 2 times 3. This is 2 times 3 raised to power 2. And this is 3 raised to power 3. Now when we want to pick, I said we're going to pick all the numbers, but we're going to pick the one with the highest power. For 2, this is the highest power. So LCM will now be 2 raised to power 2 times. For 3, this is the highest power. 3 raised to power 3. Now what is 2 raised to power 2? That is 2 times 2, 4. What is 3 raised to power 3? That is 3 times 3, 9 times 3, 27. So let's now look at 27 times 4. 4 times 7, 28. We write 8, we keep 2. Then 4 times 2, 8 plus the 2 we are keeping, 10. So LCM is what? 108. That means the result or the answer we have from the first method and the second method is the same. So following these methods, you not have issue in finding LCM of numbers in mathematics. Personally, I prefer using the second method because if you have a question that asks you to find both the LCM and the HCF, or what they call GCF, which is highest common factor or greatest common factor in other places, then doing it like this will make it easier for you. But if you use this first method, you can only use this first method to solve LCM. Then when you want to solve your HCF, you have to do it like this again. This one's going to take more of your time if you want to find both the LCM and HCF together. But if you use this one, you can just find everything at once. From it, you can find your HCF easily, and from it, you can find your LCM easily. So far, so good. That is how to understand LCM in mathematics. Thank you for watching and listening. Please help to like this video and other videos on our channel. Also, help us to share this video and other videos on our channel. Please give us your comments. We want to have your sincere feedback. Thank you. God bless. See you next time.